Yes. Okay, guys, we have already covered section 2.5. So this video is 2.5 part 2, right? Okay, there are many examples in your textbook, right? Uh, for my textbook, I'm using the whatever examples they can find. I find this example useful because if I use examples that are too complicated, you might not understand. But of course, during your N levels and O levels, eventually, the questions may be more challenging than what you see here. Okay, so now let's look at example 2.7 for today. Now, figure 2.15 shows the velocity time graph of a moving lift. Now, you need to be able to suss out the information, right? So this lift starts its upward motion from 40th floor of an 80-story building. So sometimes to help you visualize, right, must draw a building and it is 80 stories and your lift is somewhere here, 40 stories, right? Okay, so let's look at the graph. Okay, it looks like this. It goes up in this manner and then down at the other side. So the graph is as such, right? Then they ask you for part A, what is the maximum velocity of the lift? Okay, so when you look at this, this is asking about velocity, okay, on a velocity time graph. That means VT graph, right? So if you are asked to determine what's the maximum velocity, using the method that I summarized for you, you can just read off the graph and give me an answer that maximum velocity of the lift is 10 meter per second. Okay, now guys, it's important, right? Please write down the correct units. Okay, 10 meter per second. Don't anyhow hantam, okay? Don't always mix up velocity with acceleration. If you give the wrong units, there will be no sympathy. You will not be able to get the marks. And no point appealing for the scores, right? If you are not proficient in this, right? So the only way you can be proficient is by practicing lah. Okay, next. Now here the next question is, it says, for how many seconds does the lift move? Now you got to be very careful here, because here you notice, right, you have a lift, right, going, it has been moving, right, all this while, but there is a duration where the velocity is 0. Okay, where is it? I am talking about this. Okay, so for this part, right, the lift is not moving. But for the rest of the part, right, the lift is moving in the positive direction here, whereas this lift is moving, its velocity is in a negative direction. So how many seconds does the lift move? Okay, simply you can read off and see from the answer, lift moves for 60 seconds. Okay, now this is the kind of question, very simple question you can expect to get sometimes, right, in section A, right, of the so-called paper 2. So we covered this already, right? Now next, what is the acceleration of the lift in the first 10 seconds? Okay, be very careful what is it that you're looking for. So when you look at acceleration, now we are talking about acceleration in the velocity time graph. So velocity is velocity. So if you want to find acceleration, if you remember the teaching in the summary, you can find acceleration by looking at the gradient. So let's look at part C. So we are talking about first 10 seconds, right? We are only talking about this. So to illustrate, so the first 10 seconds, we are talking about this. So to find the acceleration, we look at the rise divided by the run. Okay, so here you see, here is 10, 10, 10, right? And here is 0, 0. Okay, you may be asking, hey, Mr. C, how come this one look like math? It is. So you see, leaf gains 10 meter per second in the first 10 seconds. And leaf is moving with uniform acceleration between 0 and 10 seconds. Now, it's going uniform acceleration. In case you don't remember, speed time graph, this is the graph that looks like this. And this is known as constant or uniform acceleration. So we come back to the example again, right? Okay, so in this case, to determine acceleration, right? Okay, although I ask you to the gradient, actually you can actually find the rise over run, right? So rise over run is equals to ten minus 0 divided by 10 minus 0, and what you get is 1.0 meter per second square, which is what is calculated here. Okay, so actually this one is simple calculation of the gradient. I hope you have learned this. If you have not learned this, you have to really learn it now, because you probably will be using sometime next week. I'm not saying that this will be the question that will come out, right? Okay, now next question is this. What is the acceleration of the leaf from 10 to 20 seconds? Now look, 10 to 20 seconds, right, is here. Now you look at it, right? Look at the velocity. The velocity is 10 here. Okay, it's 10 here, and then at 20 seconds is also 10. When we say 10, it's not just 10, but 10 meter per second. So what is the acceleration? Let's look at D. The acceleration is 0 meter per second. Now, this is actually comes back to the point where I need you to refer to the summary one, right? If there is no change in the velocity, it's always at 10, right? So V minus V, remember the V, A equals to V minus U divided by T, right? V minus V is 0. So acceleration is 0 meter per second square. Now, I need to emphasize to you, right? Please use the correct units. Okay, so the leaf is moving uniform velocity between 10 to 20 seconds, and this uniform velocity is 10 meter per second. So your acceleration is 0. So in other words, right, A equals to V minus U over T, right, is 10 minus 10 divided by 10 equals to 0. So this is the answer. Okay, now part E. What's the acceleration of the leaf between T equals to 20 to 30? Describe motion of leaf during this period. Okay, motion, right, you need to interpret. So between 20 to 30 seconds, right, okay, between 20 to 30 seconds, what we have now is this. So from 20 to 30 seconds, right, it goes from 10 meter per second to 0. And then you see that the speed or velocity of the object steadily decreases to rest, right? So now let's look at E, right? Okay, so if you want to look at the acceleration, once again, acceleration you can determine by using gradient. Okay, so this gradient is rise over run, right? So y2 is 0. Okay, so let me just look at this, 0 0, and here is, okay, I don't think it's 0 0. Let me rub this again, right? Okay, now let's look at this, right? This point is actually 30, 0. Okay, it's actually 30 seconds and 0 meter per second. And this one is 20, 10. 20 seconds and 10 meter per second. So your acceleration is rise over run, 0 minus 10 divided by 30 minus 20. Okay, so this is what we are talking about. So 0 minus 10 is minus 10. Then minus 10 divided by 10 is minus 1.0 meter per second square. Now you compare this, right? This minus sign, right, means something. So between 20 to 30 seconds, lift is actually slowing down uniformly in the upward direction. So in other words, right, A is lesser than 0 in the positive direction. Remember our example? Okay, if you don't remember, please refer to the earlier videos. Okay, now part F, right, they ask you what is the acceleration or leap between 30 to 35. Let's look at 30 to 35, right? Okay, 30 to 35 is here. Okay, let me change to blue pen first. Okay, 30 to 35 is 30, 0 and 35, 0. So what you have is 0 minus 0 divided by 5, right? So actually for F, right, there is no acceleration. Why no acceleration is because lift is at rest between 30 to 35 seconds. In other words, maybe the lift is at the 40th story and then it totally never move. Okay, for the 5 seconds, maybe until the next person press the lift. Okay, now G. What is the acceleration of the lift between 35 to 45 seconds? Okay, 35 to 45 seconds refers to here, right? Now in this context, this point is 45 minus 10. Okay, so you have to look at, because we are talking about acceleration now, we are looking at gradient once more. Okay, now the gradient will therefore be the rise over run. In this case, is not rise but negative rise, right? So what you have is G, right, is minus 10. Minus 10 is the second value, minus 0 the first value. Okay, now we are talking about this side, minus 10 minus 0 divided by 45 minus 35. Okay, there we have it. So you have minus 1 meter per second square. But be very careful, here is minus and this is in the negative direction and here is the positive direction. Now you have minus 1 meter per second square in the negative direction, means that the lift is speeding up uniformly in the downward direction. And remember the earlier examples. Okay, now what is the final location of the lift at t equals to 65 seconds? Final location. Now final location, okay, this is not distance time graph but velocity time graph. Now I want to ask you what's the final location all you can say is the lift finally comes back to rest on the 40th floor, right? Because when it come back to here is 0, 0. So ultimately, lift goes up. Okay, lift goes up in the positive direction. Then lift comes back down. So it goes back to the 40th floor. Okay, so this is a very good example. You might want to follow this, or otherwise just take a picture and paste the solution. But the best is you write down so that actually you know what you're talking about. Okay, next, example 2.9. Now we'll consider this example. Okay, all these examples will be good. I'm just showing simple examples so they can understand, because examples that are too complicated, you need to practice and see the answer how it's done. So here says figure 2.19 shows the velocity time graph of a car traveling on a straight road. So what's the displacement during the first 10 seconds? Now, don't forget, right? This is a VT graph. If you want to find displacement, what do? Okay, if you remember the earlier summary, displacement in the VT graph refers to the area of a triangle. Okay, which area of the triangle we are talking about? We are talking about this triangle. Okay, now this triangle you learned before, right, is half base times height. So it's half times 10 times 30 meter per second. So the best is, right, look at the units here. This 10 second, and then here is 30 meter per second. So it's half base times height, 150 meters. Okay, I hope you know how to do this. Ultimately, the best is you have units, right? Because you have meter per second multiplied by second, so it cancels out. So what you have is the distance. Okay? Now, part 2. What is the time taken for the whole journey? The time taken for the whole journey is this, right? Here is not 40, right? But look very carefully. Here is 42. So coming back, reading off the graph, the total time taken is 42 seconds. Okay, sometimes not everything you need to calculate, right? But you need to look at the question per se. Next, what is the total displacement? Now we are talking about the VT graph, velocity time graph. Total displacement will be the total area. Now you can of course sum up everything one by one. That means you consider the two triangles, right? You can do this rectangle first, followed by this triangle. Okay, maybe let me illustrate using a different pen. So you can compute this area, right? 1, or this area 2 followed by 3. You will get the same answer. Alternatively, right, you can use what is known as the formula for area of trapezium. Area of trapezium is half 20, right? How you get 20 is 30 minus 10 equals to 20. Now it's 20 seconds because the unit is 20 seconds. Okay. This is the top length, right? Is 20, but the bottom is 0 to 42 seconds. So what you do is you take the shorter length versus and the longer length, and then you halve it, right? Then you get the average length. Then you multiply by the height. In this context, right, the height is 30 meter per second. So with that, right, you have meter per second multiplied by second. In the end, what you get is distance. Then what you do have is 20 plus 42 is 62, is 31. So it's 0.5 times 31 times 30, right? So what you have is 930 meters. Now this part, right, usually is a 2-mark question. 1 mark is for the method, the other mark is for the answer. Now you should try to go after every single point. And a lot of students, due to lack of practice, they are not able to get this right. But if you practice, of course, with diligence, right, and put in the effort, you will be rewarded. You will get it right. Okay, now part D. What's the average velocity for the whole journey? Now, average velocity for the whole journey, you must take the total displacement divided by total time. Now, total displacement is 930 meters. Total time is 42 seconds. Therefore, average velocity is 22.1 meter per second. So you see here, this velocity, the way it's calculating is similar to average speed. So we sometimes, questions like this, we use them interchangeably. So why you can use it interchangeably is because, right, look at this. Velocity time graph for a car traveling along a straight road. When the road is straight, right, the direction doesn't change. So you can use speed and velocity interchangeably. Okay? Now, I hope this will help you by looking at these examples. So what I'm going to do is I'm going to stop here so that the file will not be so big. Now, if you have any doubts, you can of course ask me. But all that I know, I've taught you in this video lesson. So I hope that you'll be able to review the videos over and over again until you understand. But don't spend too much time. You really have to start doing the questions after you view the video, right? And attempt the questions and be ready for your WA in week 7. Okay? So I will end now.